Introduction to Molecules and Molecular Mass. So molecules are when you have two or more atoms bonded together. They're also sometimes called compounds, and there's molecular compounds and ionic compounds. Molecular compounds consist of just nonmetals that are bonded together, while ionic compounds consist of a metal and a nonmetal combination bonded together. So from our previous lecture, we learned how atoms are structured and how certain atoms like to gain or lose electrons in order to form ions. So many of our metals will form positive ions. Many of our nonmetals will form negative ions. And when you have opposite charges like that, they're attracted to each other, and they form these substances called ionic compounds. Now, ionic compounds are capable of conducting electricity, and that's why we call them electrolytes. So if we think about salt here, NaCl, sodium chloride, this is our table salt. This is the most common salt that we have available in our diet. NaCl, the Na part, is a metal. The Cl part is a nonmetal, so they come together to form this metal-nonmetal combination. The metal has a +1 charge, the nonmetal has a -1 charge, so we've got these opposite charges that are attracted to each other. So compounds composed of two or more elements bonded together. Elements are always combined in a whole number ratios. So there's some examples of how molecules can be written out. They can be decomposed chemically into simpler substances. Like if we look at this one, Al is for aluminum, O is for oxygen. This can be dissolved into the element aluminum and the element oxygen. Each compound has unique properties that are different from the elements that make it up. So aluminum oxide is very different from aluminum by itself and oxygen by itself. Chemical formulas specifies the number of atoms of each element in a compound. So this number 2 indicates that there are 2 hydrogen atoms in this compound. There's nothing listed next to the S, so we're assuming this is 1 sulfur. And then the number 4 corresponds with the oxygen here. So this tells us that there are 4 oxygen molecules. When parentheses are involved, we would actually multiply what's on the outside of the parentheses to each element inside of the parentheses. So if we go from left to right here, we've got calcium. Calcium, there's nothing written, so there's 1 calcium. When we look at nitrogen, there's nothing written here, but since this 2 is on the outside, we would multiply it inside. So this is actually 2 nitrogen. And here we have the 2 on the outside, so we have O3. We would multiply these together to get to a total of 6 oxygen. The formula for table sugar is C12H22O11. How many oxygen atoms are found in a molecule of sugar? Okay, so let's look at this formula. We see the 11 here. 11's next to the oxygen. The answer would be D, 11. Aluminum sulfate is a compound that's often found in baking powder. How many sulfur atoms are found in aluminum sulfate? Give you a minute to think about this. And it's 3. So we would carry the 3 over to the sulfur, and that's how many. How many oxygen atoms are found in this? I'll give you a second. All right, so in this instance, the 3 would carry in and we would multiply them. So 3 times 4 gives us 12. The formula for ethyl alcohol is listed. So how many hydrogen atoms are found? So we have 3 here, plus 2 here, plus 1. That would give us 6 total. So now we're going to calculate the molar mass of a compound. So 1 mole of a compound is 6.022 times 10 to the 23rd formula units of the compound. We're going to get into that a little bit more when we talk about what a mole is. But molar mass gets us a step closer to what is in a solution. The molar mass of the compound is the mass of 1 mole of the compound, and the molar mass is the sum of the atomic masses of each atom in the compound. So, if we want to get the mass of this, if you remember previously when we talked about atomic mass is the mass of the, it's listed on the periodic table. So that's the number of protons, neutrons, and then it accounts for the number of electrons. So that's listed on the periodic table of elements. But if we want to get the molar mass of a compound, of this whole substance here, we would have to take the mass of carbon plus the mass of oxygen to get the total. Well, carbon's atomic mass is 12.01. Oxygen's atomic mass is 16. So in order to get the total mass of all of this, we would have to add them up. But we also have to account for how many carbon and how many oxygen are in this compound. So here you can see that there's 1 carbon. So we have 1 times the mass of carbon. Plus there's 2 oxygen. So we have 2 times the mass of oxygen. And when we add those up, the total mass is 44.01 grams per mole. Now where did these masses come from? Directly from the periodic table. So if you have your periodic table handy, you can look up these masses on the periodic table. So we're going to now calculate the molar mass of each of the following compounds. So I'm going to do the first one, then you're going to pause the video, you're going to work through the rest, and then we'll do them all together. So HCl. HCl has 1 hydrogen, and I like to put these in a row. So there's 1 hydrogen. Now what is the mass of hydrogen? I have 1.008. There's 1 chlorine. So that's 1 times, chlorine is 35.453. Now when we add these up, pull out my calculator here, 1 times anything is just the same number, so we're just going to do 1.008 plus 35.453, and we get 36.461. So go ahead and pause the video and work through the next few, and then unpause and you'll see the solutions. Okay, so next one is MgO. So I'm going to put Mg and O. And there's 1 Mg. Magnesium is 24.305. Then we have 1 oxygen. Oxygen is 15.999. And we're just going to add them together. 24.305 plus 15.999 gives us 40.304. So now we have aluminum carbonate, and we are going to take each individual atom, or element, sorry, and list it out. So here we have aluminum. There's actually 2 aluminum, so we're going to do 2 times, and aluminum is 26.982. Now we have to carry in this 3 here, so there's actually 3 carbon. carbon is 12.011. And we also have to carry in the 3 here. So 3 times 3 is 9. Oxygen is 15.999. And we're going to do the multiplication and then add up what we get in the end. So you can actually do this in your calculator using parentheses. So if I do parentheses 2 times 26.982 and close your parentheses, then you can do plus parentheses 3 times 12.011, close your parentheses, plus parentheses 9 times 15.999, close your parentheses, and I end up with 233,988. So if you can't figure out the parentheses thing, what you would do is just write down the sums independently. So you could do 2 times 26.982, which gives you 53.964. Then you would do 3 times 12.011, which gives you 36.033. Then you would do your 9 times 15.999, which gives you 143.991. And then when you add those together, you would still end up with the same answer. So either method works. I like to just use my parentheses in my calculator to make it easy. Moving on to the next one. So here we have nitrogen, hydrogen, phosphorus, and oxygen. We have 3 nitrogen, and nitrogen is 14.007. Kind of hard to write on this screen at this angle, so hopefully you can read that. Hydrogen, we have 3 times 4 is 12, and hydrogen is 1.008. Phosphorus, we only have 1 phosphorus because there's no parentheses over there, and phosphorus is 30.974. And we have 4 oxygen. $15.999. Now, when we add these all up, whichever method you prefer, I'm going to do the parentheses method. So again, I'm doing parentheses 3 times 14.007, close my parentheses, plus parentheses 12 times 1.008, close the parentheses, plus parentheses 1 times 30.974, close the parentheses, plus parentheses 4 times 15.999, close the parentheses. I end up with 149.087. So on the qualifying exam, they may give you problems like this, and they may give you the atomic mass of each one of the elements. So you need to be able to calculate this out by hand. And if you can't calculate what the mass of a compound is by hand, you won't be able to answer the question. So it's really important that you don't just ask AI, what's the molar mass of blah, blah, blah? that you actually learn how to calculate it out by hand so that you're able to reproduce this on an exam where there isn't AI allowed. All right, last one here, we've got magnesium, chlorine, and oxygen. There's only one magnesium, and magnesium is 24.305. Then there's 2 chlorine. Chlorine is 35.453. Then we have 4 times 2 gives us 8. Oxygen at 15.999. And we can go ahead and calculate this. .223. All right.